Hi, everybody. I did a speech last year here. Did anybody see that? Well, that's pretty good. Yeah, last year after I did the speech here and the material started floating around, and some of it's on YouTube, on the internet things, you'll actually find the videos. I started getting some phone calls from data recovery companies and other data recovery people who were a little pissed off, to say the least. They're like, hey, dude, this is trade secrets. You're like ruining our industry, and you know, all the stuff that's you're telling people to help them recover their disk is just going to hurt us as a whole. And I made it pretty clear to them that the whole point is that if your data is worth, say, more than anywhere between $600 and $1,000, and you wanted to do something with it, you should send that off to a professional company, because there's a good chance you're going to mess it up, especially if this is the first time that you're doing something. And then the second point that I tried to make to them is that most of the stuff that people are doing is they're not going to spend $2,000 to try to get their data back. So I want to try to help them do their own recoveries and actually get somewhere. And I've had a lot of good response from people who've actually done this. So in response to their request for me not to ever do any more material, I'm here with bigger and better and more advanced stuff, and I'm actually going to follow a theme this time. So, thank you. So let's make sure this is going to work. I can tell you I've heard this story way more than once. So this is the most common question that I get. So I'm going to try to take two of the most common questions that I've gotten since I did all the presentation stuff last year. I'm not really going to duplicate, but maybe 5% of what I did last year. So the videos are out there. If you go to myharddrivedied.com, they're actually published. I have a ToorCon, DEF CON one up there. They're a little bit different, and there's more material. And I'm only going to duplicate about 5% here because it pertains to this particular problem. And then the second question that I had all the time was about multi-platters. Last year I said you can't do a recovery with a single platter. I meant you as a general audience just without any special tools, because my whole presentation is about not having to have special tools, except for this one thing where it actually has to do with a multi-platter. So I'm going to go into that. But this is a common problem that I get a question for, is what is that clicking noise? The problem with the clicking noise is that it's not a simple problem. It actually is based on 4 different types of problems that all have the same effect. So let's go through those. Basically what we're going to be talking about here is going to be the area that says the actuator arm, where the area of the head actuator arm, and then down through the logic board. So we're going to be focusing on how that is affected and what happens, and there's an item on there that's called the preamp. So I'm going to go through those pieces. The very first thing that happens when you power on your hard drive is that the hard drive has to do like a self-check. It actually checks to make sure all of its electronics are there, that all the pieces are functioning properly before it actually proceeds to do anything else. Once that has successfully completed, it will go ahead and say, hey, I want to spin up the motor. And the spindle will start to spin. The motor spinning is a very important process for the heads, because the motor spinning is what causes what's called an air bearing. The air bearing causes the head to float, and that's what actually allows you to move your head over the platter. But it does one other thing, which is on the left there, blinking in red, you'll see that there's a locking pin there. It's actually just a little piece of plastic that just teeters out of the way when the airflow is strong enough to push it. So once the platter starts to spin up, it'll move that out of the way, which unlocks the arm so that it can move over the platter. So as soon as it starts to do that, it will start to unmount the head once the head has an OK, and then it causes it to fly over the platter. So this is what's going to keep that going. Then the head actually has to go and read what's called the servo timing. The servo timing is a mechanism on the drive that is like geographic information. It's going to tell the head where it is over the platter at any point in time. So it reads that information from the platter, and then it starts to read firmware on the platter. The platter will actually have contents on it, and each manufacturer can specify certain things that they want to do with this platter and store in content. So if there is some special test routine they will write that content typically on the platter so that they don't have to make adjustments or change the board every time something changes. They can just make a change to the content on the platter. So the way they do this is with something that's called the system area. So every manufacturer has their own specific system area. And this is what makes it really difficult to do any kind of recoveries if you have damage here, because everything is specific to a manufacturer and sometimes to a model. So in order to repair this, you've got to imagine that it's kind of like getting a firmware update for your board. It's like they're all specific. They're all going to be individual, and they're all going to be even more specific by model. But most of you have heard that you have maintenance tracks or negative cylinders on your drive, and they typically are numbered negatively. So you will have a 0 track will start where your data is, and everything else before that is actually a negative number, and they can have a ton of negative tracks, but typically you're looking at something in the range of like 20 negative tracks. This is the type of content that's in the SA area. Now, in the data recovery world, this is called a UBA block, and that's utility block addressing. And each one of the UBA blocks is a module. So smart data, most of you know what that is. There's actually a spot on the platter in that negative area where it can store the smart data. Some drives store their serial number there. Some of them actually still have them on the boards, the PCB boards. So if you're going to change something out, there's a specific reason why I'm telling you about these particular items, though. And as I go through the recovery process, you'll see why these items are important. The P list and the G list. Some of the firmware overlay code is important if you've got special tools to recover the data. And then you have all your servo parameters and your test routines. This is what a UBA block looks like. Basically what they did is your drive has sectors on it, and each sector is 512 bytes. Well, when they decided that they wanted to have a utility block, they don't want to have to say, I have 7 sectors for this block. So they came up with what they call the UBA block. And so the UBA block is where they define that now in a table, and they say, on this drive, for your bad block list, maybe I have 3 sectors. And for this one, for the drive ID, I only have 2 sectors. And the manufacturer can change this at will, and then they don't have to change any of their code to read what is happening on the drive. They just change the size of the UBA block. So it makes it a little bit easier for them, and you can actually address the UBA blocks using certain special equipment that says, I want to go read what the bad block list table is, and pull that up. This is just an example. This doesn't mean that it's written in stone, and everybody's is different, and every drive is different. So the system area has this thing that's called the P list and the G list. Most people know that they have a bad block list. The thing is that you have more than one bad block list. You have 2 bad block lists. There's a really important reason that you need to know that you have these 2 bad block lists. And again, when I get to the data recovery section, I'll show you how to do what's called a live PCB swap. And if you have this loaded, you'll have to know that it has changed and what to do about it. So the P list is the primary list. When they manufactured the hard drive, they scanned it, formatted it, did a number of different things to the drive to test it, and everything that came up as a bad block, they went ahead and put in this list. So the primary list is a permanent list. It doesn't change. You don't normally erase it. There are special tools that you can use to erase it. And then the G list is the bad block list that you know of that's called the grown list. And that's where all the sectors that have problems while you're reading and writing to your drive are written to. And that can actually be cleared. You can do a number of different things with that, or test and add to the list. The problem is that if a drive head has not read and written to a particular sector in a long time, the environmental aspects of that disk can change, and a sector can go bad. And it won't be added to the bad block list. You'll actually get like, my hard drive doesn't boot. It just dies. And you'll have a number of different problems, and those are the kind of things where with doing different ways of recovery, you can actually get those sectors back or rebuild those sectors.